Alright guys, welcome back to this channel, and in this video I'm going to be evaluating this Laplace, inverse Laplace. But before we proceed, if you know you have not subscribed to this channel, kindly do so that we can be encouraged to shoot more videos of this nature subsequently. So we want to find the inverse Laplace of 5 over x plus 2 to the power of 4. Okay, so the first thing we want to do is to separate this guy. We can write it like this: 5. We can bring out the 5 since it's a constant. Then we'll have something like this: the inverse Laplace of 1 over s plus 2 to the power of 4, right? That's 1. And we also want to recall from our Laplace property that the Laplace, okay, the Laplace of an exponent to the power of a t and ft, basically it's something like this. It's actually f of s minus a. We want to know this, and since we have this in mind, then we can proceed from whatever we want to do. And again, we want to also remember that the Laplace basically of t to the power of n, of t to the power of n, is n factorial over x n plus 1, right? So having known this, it's very obvious that we know that we are working with a t function. Okay, so let's just use this idea to get what we want to do, to get it done. So now that we have this, I can also write this particular equation in this form. It can be that the inverse Laplace of don't forget that we have 5 here. Then we can have, because we want to work towards the what I wrote earlier as regards t raised to power n. We said it is n factorial over s raised to power n plus 1. So we have 4 here. So I want to write something that will be in terms of 4. So that will be 3 factorial over s plus 2, 3 plus 1. That's like our n plus 1 and n factorial. But if I should do this, I have altered the question, because in the question I don't have 3 factorial. So what do I do to take away this this utterance? So this can also be written as 5 times the factorial, right, which is bringing out this particular guy, bringing it out. Okay, so now to cancel it out, for sure I can write this as times 1 over a 3 factorial. It will cancel it out. Okay, so if I can write it this way: 1 over s plus 2, 3 plus 1. Okay, since if I can write it this way, then I can now write my whatever I want to write in a very, very simple form, like 3 factorial, the inverse Laplace of 3 factorial over s plus 2, okay, then 3 plus 1. So I've been able to write it in this form here. Okay, so since I've done that, then I can now explain my answer. Don't forget that at the beginning of this video, I said that you can have EAT FT is equals to Fs minus A. So that's exactly what we want to apply. So in this case, I've vividly seen that I can write it as 5. 3 factorial is 6. Okay. Now, I've been able to get my n. This is my n, and this is also my n. Okay. Let me make it a brighter color. This is my n. Okay. This is also my n, which means that I'm working with a t function. But there is something here. This is not s. This is s plus 2. So our final answer, considering my f of s minus a, will be exponential minus a 2t, right? Then t raised to power of 3. Because this guy here made the s that we're supposed to have for ordinarily, if you have 3 raised to power t raised to power 3, we'll have 3 factorial over s raised to the power 4 as per 3 plus 1. But because there is an exponential, this s will now be 3 factorial s minus whatever we have there, which is minus 2. Do you get the point now? Then raised to the power 4. So that is why this is actually equals to this. So in conclusion, our final answer for this question will be that 5 over 6 exponent minus 2t, then t raised to power 3. Thanks for watching, and I will see you in the next video. Don't forget to like, share, and also subscribe to this channel.